Today, we're going to dive into the fascinating world of plasma cosmotheology and plasma cosmology. Let's start with the basics. Plasma cosmology is a non-standard cosmology that suggests that dynamics of ionized gases and plasmas play important roles in the physics of the universe at intergalactic and interstellar scales. It contrasts with the widely accepted Big Bang theory, which explains the formation and evolution of large-scale structures as dominated by gravity. The term plasma cosmotheology is a blend of plasma cosmology and theological concepts. While plasma cosmology is a scientific field, cosmotheology typically refers to the study of the universe from a theological perspective, often exploring the relationship between cosmology and religious beliefs. Now, let's imagine how plasma cosmology could intersect with theological ideas. In creation, in traditional theology, creation stories often involve a divine being shaping the universe, right? Well, in plasma cosmotheology, one might speculate about the universe being formed and influenced by vast cosmic plasmas, perhaps as a manifestation of divine will or a cosmic force. Eternity. Plasma cosmology or cosmotheology might propose an eternal universe, constantly evolving and changing through the interactions of plasma rather than having a singular beginning or end. In life and consciousness, some might explore the idea that plasma, with its dynamic and complex behavior, could be a fundamental component in the emergence of life or even consciousness on a cosmic scale. That's crazy to think, but the evidence supporting plasma cosmology is based on the idea that plasma, which is the fourth state of matter, plays a significant role in the dynamics of the universe at various scales. Here are some points that have been presented as evidence for plasma cosmology. The abundance of helium. One argument is observed the abundance of helium in the universe, which some proponents of the plasma cosmology suggest provides a more accurate understanding of plasma behavior and the role of gravity. Galaxy formation. The theory suggests that the galaxies are slowly forming within galaxy clusters and stars evolve over billions of years, which could be an alternative explanation to the Big Bang Theory's rapid galaxy formation. Scaling. Hans Alfvén, a key figure in plasma cosmology, proposed that results from laboratory plasma experiments could be scaled up to cosmic distances, suggesting that similar processes observed in the lab could be occurring at the scale of the universe. But it's important to note that plasma cosmology is not widely accepted in the scientific community for some odd reason. It should be. Most cosmologists and astrophysicists favor the Big Bang model because it aligns more closely with the current observations in astrophysical phenomenon. Very few papers supporting plasma cosmology have appeared in literature since the mid-1990s. Critics of plasma cosmology argue that it does not match the observations of astrophysical phenomenon as well as the currently accepted Big Bang model does. Additionally, there is no experimental or observable evidence that dark matter exists, which is a theory to make the Big Bang work. While plasma cosmology presents an interesting perspective, the lack of substantial supporting evidence and the stronger explanatory power of the Big Bang theory have led to its marginalization in the cosmology field. But that's it for today's lesson on plasma cosmology. Remember to keep an open mind, stay curious, but also to critically evaluate ideas based on evidence and scientific principles that you can find. Class is dismissed.